Thank you very much. I think you might have just done the first half of my intro for me, but let's get going. So, hello everybody. My name is Jo Franchetti. It's really, really lovely to meet you all, and thank you so much for inviting me to speak. It's my first ever visit to Russia, and it's been absolutely incredible so far. You might have noticed, and I should apologize, that this talk will be in English because my Russian is non-existent. Even though some people tried to teach me some Russian in the pub yesterday, they also gave me vodka, so it didn't combine well. Anyway, you can find me at This is Jo Frank on Twitter if you're on Twitter. I also blog at Jo Franchetti on Medium if you're interested in reading more about the sort of demos and tutorials that I write. I'm a web developer advocate for Samsung Internet. If you're not sure what a web developer advocate is, well, my team, we run events and we speak and we run workshops, and the whole point of what we do is to teach people about new web APIs, to get them involved in new web technologies, and to get them using the web in the best way that we can. We want you all to have the best experiences that you can when you're browsing the web, so that's what our team is for. We're super friendly. We really love it when people show us the projects that you're working on. So if you're using WebVR or Web Bluetooth or CSS Grid or any of the new web APIs, like, come show me your project. We'd love to feature it. We'd love to talk about it. And if you've not heard about Samsung Internet, well, now you have. We're a web browser for your Android phones. So anyone on Android 5 Plus can download the browser. It's built on Chromium, which is what Chrome is built on, but we try and turn on APIs a little bit earlier, so we'll turn on support, like we were one of the first browsers to have support for CSS Grid, and that was because you had all fed back to us that you wanted CSS Grid, and that's what we try and do, talk to developers and give them the APIs that they want earlier. We're also really keen on privacy and security. So unlike Chrome, we have ad blockers and tracking blockers built in. You just need to press a little checkbox and you're secure and you won't be tracked. I've got some stickers up here. If any of you would like them, come talk to me afterwards. Gentleman who got the socks, there's a Samsung Internet pair of socks here for you. Anyway, we're here to talk about Intersection Observer. So why do we need or want this new API? Well, let's talk about some common problems that we might run into when we're building for the web. So often, I mean, I'm sure a lot of you have worked on sites that have a lot of images on the first page, and especially if those images haven't been optimized, they can really slow down your initial load. Or maybe you might want to do infinite scrolling, the kind of thing I'm sure you've seen on Twitter or on Facebook, where you scroll to the bottom and more content loads. Or maybe if you've got adverts on your page, there's a rule the Interactive Advertising Bureau has set that your ad has to be at least 50% visible for more than 1 second in order for you to be allowed to make revenue from that ad. And in order to work out whether the ad is in screen, you're having to run a lot of JavaScript, you've got a lot of polling on the main thread, you've got a lot of processor power being used, and it can really slow your website down. And calculating the position of the scroll isn't a great way of doing this either. So it's not too far out there that you could maybe consider a website that's got infinite scrolling, that has a lot of images, that has adverts as well. You can sort of start to understand why this page might go really slowly, why your initial load might be, in the multiples of seconds, which is really not what we want. And the developer might not even realize that this is happening. They might not realize that these are the things that are causing the janky scroll on their website. So what we don't want is this sort of sluggish, janky interactions. We don't want large initial downloads for our users. Say your homepage has 60 images on it. That's a lot for your user to download before they've even decided that they're actually interested in your product or your site. They might not even scroll past that first page view if they're not interested, or if your site is too slow, then they're never going to see the rest of those 60 images that you downloaded for them over their 3G connection that they're paying ridiculous amounts for. The other thing that I haven't mentioned is third-party scripts. We don't want to have to use third-party scripts in order to calculate our scroll position. We want to be able to understand the code that we've written. So what do we want? We don't want to have to watch or poll for intersections. We don't want to be running these processes on the main thread. And we want to have control. Oh, there we go. There's our third parties. We want to have control over the file size of our website. We want to have control over the code. How many of you have used the library where you've downloaded it, you've installed it, you haven't looked at it, you just know that it works? And that's not really what we want. We don't want code on our site that we don't know what it does. We don't know if they've written it in the most optimal way. And what if they, update it and suddenly it doesn't work with our site, or vice versa? We want to be able to understand and manage all of the code on our site. So what can give us all of these things? The Intersection Observer API. It's a new API that is going to let you detect whether an element is visible within the viewport or within a parent element that we are going to be watching. So if we have a look, this is what the spec says. The Intersection Observer API provides a way to asynchronously observe changes in the intersection of a target element, so this is the one that we're watching, with an ancestor element or with the top-level documents viewport. So the Intersection Observer API allows you to configure a callback that is going to be called every time your target element intersects with the device viewport or with a specified element. For the purpose of this API, that element is called the root. And typically, you're going to care about whether or not it's the viewport. But let's have a look at an example. So here I've got oh, it's teeny tiny. So you should be able to see, is that big enough? So I've got a square there that's currently 100% in viewport, and as I scroll, those numbers are going to change. So the Intersection Observer is telling me how much of it is in view. And it should also work. I can't read that. Where's my inspect? If we take the viewport down this way, there we go. It works that way as well. So hopefully you can see that this might be useful. Where is my mouse gone? There we go. So whether you're using the viewport or some other element as the root, the API works exactly the same way. It's going to execute that callback function whenever your target element crossifies a specific amount of intersection with the root. And the degree of that intersection is called the intersection ratio, which is going to be a value between 0 and 1. So what might we use this for? Well, the example that I worked on very recently was lazy loading of images. I'm sure a lot of you have worked on websites where the homepage has a lot of images on it. Maybe you as a developer don't actually have control of those images. Maybe they're being uploaded by a content manager, and maybe that content manager doesn't know how to optimize images, and they're uploading images that are maybe 3,000 pixels wide for an image that needs to display at this size. And suddenly your page is taking like 10 seconds to load. So I used to work at Live Nation. I'm going to show you an example of the website now, if I can get to the tab. There we go. This is the Live Nation homepage. They're a company that puts on gigs. As you can see, there is an awful lot of images on this page. I mean, a lot. And even these tiny images here are uploaded absolutely huge sizes. And the page load was so slow that our users were navigating away before the top half of the page even loaded. They were getting so frustrated by the fact that they couldn't see the content, they couldn't interact with the content, that we were losing a lot of revenue. So what we decided to do was to employ Intersection Observer to lazy load those images. I mean, I don't know if you saw when I loaded the page, we got that nice little fade in as the image is loaded. And then as I scroll down, let's clear the cache. Oh, come on. As I scroll, those images fade into view. And that's our lazy loading in action. This is specifically important because if we take it down to maybe mobile size and then look at what our users are actually going to be seeing on initial load, they're going to be seeing the top half of this page here, which means they're going to get a maximum of 1, maybe 2 images on that first load of the page. They're certainly not going to want you to download 60 images on their data connection. So let's jump to example number 2. Come on. Oh, there's a really nice blog post written by my colleague, which is there. I'll tweet these slides out later so you can follow all of these links yourselves. So another example of when you might use this API is for infinite scrolling. You've got maybe potentially infinite articles that you want to load into the page, but you want the user to be able to interact with the page quickly. So you load enough articles to the page to fill it, and then once the user scrolls, you're going to load more. Once they scroll down, you're going to load more. And the way that we do that is by using something called a sentinel. Not one of these sentinels. A sentinel is an element that we're going to choose that we know is near the bottom of the page. So we're going to give that a specific ID. That's the one that we're going to be looking at with Intersection Observer. Once we scroll to that, we're going to then trigger the load of the next load of content, and we're going to move the sentinel down to below that content that we just loaded and continue on. So it's time that we actually start to look at how we might do this. So in order to observe an element, we first need to create the intersection observer, which is what is done down here. You call its constructor and you pass it a reference to a callback function, which is the thing that's going to be run whenever that intersection threshold is crossed. Setting a threshold of 1 here means that we want the element to be 100% in view when the callback is going to be invoked. Intersection Observer delivers your data asynchronously, and then the callback code will be run on the main thread, which is why this is so great. So we've got this options object here, which can be passed to the constructor, and you can sort of change the circumstances under which the intersection observer callback is going to be invoked. And it has the following fields, so I'll just talk through them now. So we've got the root, which is usually the viewport by default, but if we set it, that's the element that we're going to be scrolling. So that's the parent of the target element that we are observing. Or it must be an ancestor. It doesn't have to be the parent, but it must contain the element. You must be able to scroll it. So if I illustrate that, it's going to look like this. So we have our root, which is our container and is scrolling, and we have our target, which is going to scroll in and out. Next up in our options object is this root margin, which essentially allows you to either grow or shrink the area that is going to be used for intersections. So it takes values similar to CSS margin. So you can give it 1 value or 2 values or 4 values. And that's going to define when the callback's invoked. They can be positive or negative numbers. And if you specified a root element, they can be percentages or pixels, but it defaults to 0, so it defaults to the edge of the element. To illustrate, because it's not instantly obvious, so if this was a positive root margin, then my callback would be invoked at the point at which it intersects with the margin and not with the element. And if the numbers were negative, my callback wouldn't be invoked until it had actually scrolled into that margin area. Then the final piece of our object is this threshold here. And that indicates the percentage at which the observer's callback should be executed. So if you want to detect maybe when the visibility passes 50%, you'd use a value of 0.5. If you want the callback to run every time it passes another 25%, you can give it an array. So we could give it brackets 0, 0.25, 0.5, 0.75, and 1, and it would happen every 25% of the target element scrolling into view. It defaults to 0, which means that that first pixel that crosses the line, that's when your callback is going to be invoked. So again, let's take a look at how that would look visualized. So for example, if we'd set it to 0.5, so we wanted it to trigger every time 50% of the element scrolled into view, the callback would be invoked the first time it scrolled into view, and then it would be evoked again as it scrolled out of view. So once you've created your observer, you need to give it a target to actually observe, which is going to be the element that you're interested in. And then whenever your user scrolls and that target is reached, the callback is going to receive a list of intersection observer entry objects. So those are what you're going to use to then load an image or do whatever it is that you want to do with the observed element. So let's take a look at what you actually get from intersection observer. I'll talk through each of these. So BoundingClientRect gives you the result of using getBoundingClientRect on the observed element itself. So this is the element that you're looking at. The intersection ratio is what we talked about before, so it tells you how much of the element is visible. If we were going to, for example, check whether an image should be in view and then load it, the intersection ratio is the one that you'd want to be looking at. So then we've got is intersecting, which is either true or false, if it is intersecting or not. We've got root bounds, which is the result of calling getBoundingClientRect on our root element, so that's our container element. And you can see these by using the inspect tool when you call the observer if you want to. So let's go back to our lazy loading images example. If we wanted our images to load nice and smoothly, we give them all a very tiny source image, so like a 1 pixel by 1 pixel source, and we set the actual source of the image to data source. Then what we'll do is we'll use our intersection observer to check whether any of the images are intersecting, and if they are, we'll swap the source over for the data attribute for the source. And while we're doing that, we'll also write some CSS with a nice sort of blur animation, so when the images load, they blur in nicely and your user doesn't realize what's happening. So hopefully by now you're all excited and you're going to go back to your websites on Monday, Tuesday, and start using Intersection Observer. There's one thing that we need to talk about before you do that, which is the support. Yeah. So Internet Explorer and Safari, nothing ever works in Internet Explorer, so I don't know why we even bother to look, but it's there in Edge and Firefox and Chrome. This image is actually out of date. I can't lie to you. Come on, mouse. There we go. Is this it? No. No. There we go. This is the actual in-date one. So Samsung Internet did implement Intersection Observer, implemented it slightly differently to what is now the spec. So we are currently light green, which means that if you're using Intersection Observer and you care about Samsung Internet, which you should, you might need to check is intersecting as well as the intersection ratio, just to make sure that you're definitely going to get the trigger at the right time. Sorry about that. We'll fix it in the next update. So there's a few other things that we should talk about before you dive into Intersection Observer. Oh, come on, mouse. Something that you should keep in mind is that Intersection Observer is intentionally not pixel perfect, and it's intentionally low latency. The thing that we're going for here is stopping that kind of jankiness of running lots and lots of calculations. So that's not what it's doing. So if you want to use it to implement things like scroll-dependent animations, that's not what it's for. Like your animations are going to trigger at the wrong times because the data that you're getting from Intersection Observer is going to be out of date before you've even started the animation. And also, if you try and do lots of work in the callback, you're still going to make your site slower. So is it worth it, is what you're asking. I have made a couple of examples, and then I'll show you a real-world example as well. I made a couple of websites. I'm not a designer, so don't judge me. This is my beautiful cat gallery website, and it has a lot of images in it. And as you can see there, I've got lazy loading on here, so the image is blurred as they came into view. I also made a version that doesn't have lazy loading on it, and I ran it through a web page speed test. Just out of interest, how many of you use web page speed test? Good. How many of you use Chrome's Lighthouse? Oh, more for web page speed test. That's what I like to hear. Okay. So for those of you who aren't familiar with web page test, we'll test your performance. So it'll give you information on things like time to first load, time to paint, time to interactive, the size of the download, the size of your scripts, how many images you're loading, which is all things that you really should care about as developers. And you should be testing in this regularly and trying to improve. So if we go back now. So this is the test results for my first example, which didn't have the Intersection Observer. So the things that I want you to notice are the start render speed, is that 5.3 seconds? And then the speed index there is 5,400 and something. And the request, there's 34 requests, so there's 34 images in there. I'll just talk through each of these stats. So that start render is really bad. There is a lot of research into this, and there is science that says if your start render is slower than 4 seconds, that is catastrophic to user engagement. Your users will just leave you. They can't be bothered to wait longer than 4 seconds, especially if they're not already engaged with your brand. Speed Index recommends that you want to get a score of 2,000 or below. 5,000 is terrible. And 34 requests means we're loading 34 images initially into the page. So let's compare this with what we get after. We just use, maybe 12 lines of code to implement Intersection Observer. First of all, our start render has massively reduced. And that's because we're only loading 15 images in this time, and our speed index score has gone down to 1,000. And this is a bit of a silly example because there's no real interaction. There's not even any links on this page. So let's talk about an actual real life example, which is that Live Nation website. Okay, so again, this isn't very easy to see. So we took the stats from that homepage that I showed you earlier, which is got an awful lot of images. You can see there's 66 images there being loaded. And then the other thing that is of interest here is, let's have a look. So the request payload has now reduced massively if we sort of jump between the two. So our image, the number of bytes that we're loading initially has reduced quite a lot. If we go back again, the number of images has gone from 66 to 29. And our time to load, which was previously 5.5 seconds, which is when our users were leaving us, we managed to reduce down to 3.5 seconds. And I know that doesn't sound like a lot, but getting it below that 4-second mark is really important. And our start render dropped from 1.6 seconds to 1 second, which is amazing. And our speed index score dropped from 4,000 to 2,800, which is, there's still work to do, but it's a good initial gain. So hopefully you're excited about this now. You're going to make your websites better, and go forth and observe intersections. But wait, there's one more thing I want to talk to you about. If you are interested in performance and you want to learn more about more performance techniques, I am running a conference in London in May called Delta V, which is all about how you can improve your website performance. If you want to come, it would be amazing to see you there. And that's me. That's what I got.
Ребята, поднимайте руки и помните, что не страшно спросить по-русски. Если что, мы переведем. Все ок. Но пока рук нет. Ладно, ты будешь вторым. Можно я спрошу первый? May I ask you the first question? So, can you share with us any examples how to decrease your website performance using this intersection observer, like any anti-buttons?
So if you, as I mentioned earlier, if you're using it to, maybe you want to have a particular animation happen, and then you're using it, like that first example that I gave, what I was doing there was checking every single pixel of the page, so that when it scrolled, it calls that callback every single time a pixel moves past. And if you've got your callback doing something that's more than just changing a percentage, then, I mean, that's gonna be terrible. You're gonna be calling that callback constantly.
В общем, для тех, кому не переводят или кто, в общем, смысл в том, что анимации, как обычно, вы понимаете, не надо каждый пиксель отслеживать, иначе все просядет. Так, я тебе обещал микрофон.
Yeah, okay, thank you for the speech. As first, my question is, as I understood, the lazy loading is the most useful use case for this technology, and maybe there are some other use cases it can be implemented.
Yeah. So, well, the other main use case is the infinite scrolling, and also for checking your ads and whether they're in view. I also had someone come up to me when I gave this talk in London and say that they'd made a game with it, like a side-scrolling game that changed the layout every time the user tried to walk off the side of the screen. Those are the three main uses of it, and then there are some other people who are doing exciting things with it that I maybe wouldn't recommend, but it's an option.
Hello, thank you. What will be if I use observe intersections in browser which don't support it?
Sure. So there are polyfills. The polyfills obviously are not asynchronous. So what will happen with the polyfill is it'll be either doing a check on the scroll event, or it'll be polling constantly on a timer, and it's kind of going to introduce the exact opposite of what you wanted to happen. But then it depends on how big your number of users who are using IE or Safari are as to how big a problem that is. And if that's how you were polling anyway, if that's how you were perhaps doing lazy loading or doing infinite scroll anyway, then they've not really lost anything, they just haven't gained anything. But yes, there are quite a few polyfills available. And what you would do, for those of you who aren't sure, you would check whether intersection observer is on the window and then load the polyfill if it is, and if it's not, use intersection observer. No, the other way around. Yes.
Hi, thanks for speech. I'd like to ask about, well, you know, maybe there is a standard issue when you use new API, sorry.
No?
Any browser may have its own standards, which may have extremely different results when you try use this API. Can you say something about such cases?
Sure. So that's exactly the problem that we had, which is why Samsung Internet is now light green instead of green. So we implemented Intersection Observer slightly differently to how Chrome and Safari and Firefox implemented it, which meant that the number that you were getting back from the intersection ratio was different to the number that you were getting back in Chrome. And as with all new APIs, sometimes the browsers are going to make mistakes, and sadly the only way that I can tell you to deal with it is to do a lot of testing. The way that, because before I was working at Samsung, I was working at Live Nation, and we found this exact problem. So we ended up, as I said, having to check whether the intersection ratio was greater than 0, but also check whether is intersecting was true. And just by adding that extra check in there, we caught all the browsers that support it.
Hi.
Hi.
Thank you for your speech, and I have one question. As you see, there is one big downside. Intersection observers are not supported in Safari and iOS. Do you know about any plans to implement this feature in the Safari iOS WebKit?
I don't actually know what Safari... I mean, Safari isn't usually too far behind the others. The only thing I can recommend is just checking the spec and see whether Safari have it in their plans for the future. But off the top of my head, I can't tell you about Safari. Sorry.
Thank you for your talk. I have a related question, which is what are you working on right now? How your roadmap, how your pipeline looks like?
So is that a question for me personally, or is that a question for the Samsung Internet browser? We've just rolled out web payments, which is really cool for us. So a lot of what we're doing at the moment is teaching people how to use web payments. Stuff that's coming in the future, WebAssembly. I don't know if any of you started using that. That's a big one. Yeah, I think that's the next big thing that's coming. Like, I'm trying to think of other things off the top of my head. Support for display content and display subgrid in CSS. I think that's in the works as well.
Any questions? Вопросы еще какие-нибудь, ребята? Еще раз, мы переведем. Можно спросить по-русски. Ничего страшного. Что? Про полифил, just interpret a few words about polyfills.
Sure.
Про полифил мысль такая, что да, нет, не во всех браузерах есть Intersection Observer, и там, где его нет, можно использовать полифил. Но полифилы... Да, полифилы есть, их много, но полифилы работают очень плохо. Они завязаны на скролл, их нужно отслеживать либо там через request animation frame, либо еще через что-нибудь, либо они подгружают по какому-то set тайм-ауту, что тоже не очень как бы. И в итоге этот API придуман для того, чтобы сделать все асинхронно и никак вообще не отвлекать основной поток JavaScript, а тут получается то, что мы наоборот хотим какую-то фичу сделать, а она только отжирает у нас ресурсы, поэтому, наверное, не стоит ими пользоваться, вот и все. Скорость у нас совсем другая. Скорость другая, да. Но это все про то же самое. Еще? Нет? Все как обычно. Джо можно будет поймать, сами знаете где, больше ничего продолжать не буду. Давайте еще раз поблагодарим.